Hey everyone, today we're going to talk about what a series circuit is and how to calculate a series circuit. So let's get to it. So see there on the left, a series circuit is a circuit in which there is only one path for the current to flow through. There is ways to create circuits that have multiple paths. For the case of the series circuit, it is just one path, it is not multiple paths. What's important to note is that if one element in a series circuit is burnt out, the entire circuit does not work. So Christmas lights used to be this way, where you had all the lights strung on one wire, and it used to be that when one burnt out, the whole light string did not work. That would be an example of a series circuit. So you see there in the picture, I'm going to kind of use my cursor to show you. In this picture, this would be like a drawing of an actual circuit. Over here on the right side is a schematic and how it's drawn. So I want to kind of give you a heads up. Whenever we draw a circuit, you have what's called a battery, or the charge pump is also sometimes what it's called. In this case, we have the battery. It could be an alternating current generator, but in the case of what we're usually drawing, it's just a battery. And so then if you keep looking at this picture, the battery is here on the left. We always draw that battery there on the left. And the current's going to move around clockwise around the circuit. These little squiggles right here represent resistors. And resistors can be anything that takes charge to operate. So for example, in that picture you see there would be light bulbs, right? So in this picture, you would draw, you have a 90-degree angle to show kind of where that goes, and then for each resistor you just draw a squiggle, and that would be how you indicate an object that takes charge. So in terms of how you number them, that'll be important in just a second when we do some calculations. You always think about going clockwise around the circle. So this would be the first resistor that we get to. Then one on the right there would be the second, and then of course there on the bottom would be considered the third resistor. So that's how you would think about the direction that things are moving. All right, so how do we go about solving circuits? So we're always solving circuits. We're going to be looking at, okay, what is the voltage in the circuit? What would be the current within the circuit? The resistance in the circuit? And then sometimes you're going to be looking at what's the power of the circuit also. Not always, but there are times in which we're going to be looking at that as well. So I just want to kind of mention that. So in terms of the fact that you have only one path for the current to flow, when we talk about current, we know that the total current that exists in a circuit is going to be the same current that flows through the first resistor, same current that flows to the second resistor, and then so on and so forth for however many resistors you have in your particular example. Because there is only one path for the current to flow, our voltage, however, is slightly different. The total voltage that's provided at the battery, so let's say 20 volts for a battery situation, would be, okay, once the voltage, essentially each resistor is going to take a piece of that voltage until at the end you have nothing left. Okay, so what that means is the voltage at the first resistor is going to add to the voltage of the second resistor, and so on and so forth to give you the total which exists at the battery. So I'll kind of write total over here just so that you're aware. Okay? In terms of the resistance of our circuit, it's exactly the same. So the total resistance in our circuit, okay, would be basically adding all of your resistors together. So that's a pretty simple case here. So I'm going to add the first resistor plus the second resistor, and then so on and so forth depending on the scenario. Okay, so that's kind of like the general information of how you would go about solving a circuit. I want to go ahead and do one with you just so you kind of get an idea of what that's like. Okay, so in this case, we only have two resistors. Okay, you see there, we've got all that information listed. It kind of shows you V1, V2. What I'm going to do is I'm going to make a big version of this table here, and I'm going to write some extra things to kind of help you when you're creating your tables at home to work. So here is the total column, and then we only have two resistors, so I'm going to kind of list that there, and I'll grab another color for myself. Okay, so whenever you're looking for the total information, that would be given at the battery. So here would be the information for the battery. We show a voltage as sort of something like two pieces there listed across, and it's going to show you that. So my total voltage in my circuit given from the picture would be 90 volts. Okay, In this picture, notice again, we're going clockwise in terms of numbering. So we've got the first resistor here, the second resistor on the bottom. If we had one there, that would be the second resistor, but in this case, we only have two. So it's telling you the first resistor's value is 10 ohms. So underneath the one column in the resistor section, the resistor row, I'm going to list that as 10 ohms. And then it tells you that the second resistor's value is 20 ohms. Okay, so going back to our understanding of how we solve this circuit, I want you to think about when we look down the column, okay, we know that thanks to Ohm's law, V is going to equal I multiplied by R. So when you're looking down the column, you can think of it this way. V is equal to I times R. So whatever the top line is always going to equal whatever the second row is multiplied by the third row. Okay, so that's how we look at those three things. When we go across here for voltage, we know that the total voltage in our circuit would be the addition of the voltage drop across each resistor. So I'm going to kind of write some extra things here for you. So the total is going to equal the first voltage plus the second voltage. I'm going to leave that blank for now since we don't have that information. In terms of for a series circuit, our total current, which we do not have currently at this moment in time, it's going to equal the same current that goes across the first resistor and the same current that goes across the second resistor. Again, you don't have to do these. This is just a way to help kind of, think about what that would mean for you in terms of calculation. For our resistance, the total resistance that we currently don't have is going to equal the resistance for each of the resistors in your circuit. Okay, so when you think about solving a circuit, it's sort of like finding answers in a puzzle. All right, so that's kind of what I'm doing here. So my given information was I was provided that it was 90 volts across the battery. I was given the value for the first resistor and the value for the second resistor. So kind of working backwards and thinking about this puzzle, the first piece that I can go ahead and do would be, what is my total resistance? And I do that by adding this 20 ohms with the 10 ohms to get a total of 30 ohms here. Okay? So my next piece in the puzzle would be, okay, I have two things missing here. I have two things missing there. Really hard to find the voltage since I have these two things missing. I have no idea what the current is because I don't have that information. However, looking down the column, right, we know that V is equal to I times R. So if I think about, if I were to write it out, right, 90 volts for my total is equal to I don't know the value, but I do know the total resistance because I just found it, right? I would just take 30 divided to both sides. So 90 divided by 30 is going to give me a total of 3 amps. And to kind of double check myself, 3 times 30 is going to give me 90. That makes sense. From here, I can go ahead and fill in this entire row. That can be one of the first things that you do in a series circuit. If you know the current for every single resistor, no matter how many there are. All right, now the last step is to fill in the last two pieces. Really simple, down the column, as a reminder, V equals I times R. So 3 times 10 is going to give me 30. And then 3 times 20 is going to give me 60. To verify, 60 plus 30 gives me 90. And so that's how you would tackle a series circuit. The more resistors that you get, the more complicated this table or longer this table would become. You would just want to add additional columns as you needed to kind of help you with that. Hopefully this video was helpful. Let me know if you have questions.